Hi everyone, and welcome back to Organian's Puzzle Box. In today's video, we're continuing from the previous tutorial where I showed you how to build a custom first-person camera system in Unreal Engine, with much tighter control, the ability to walk around, and dynamic depth of field when looking around the world. But this time, we're taking it up a notch. We'll be upgrading that system with a bunch of new features, and as always, the full template will be available to download for free from my Patreon page so you can actually follow along. With that said, I highly recommend watching the previous tutorial first if you haven't already, just so everything we're doing here makes sense in the context of what we're doing. Now in this video, we're going to fine-tune the depth of field to make it work more seamlessly, whether you're up close or far away from objects, and we'll also add a zoom feature that dynamically focuses on what you're looking at. On top of that, we'll be adding a slow motion system so you can trigger bullet time or slow down the world with a button press. And we're going to implement the dynamic head bobbing for the first-person camera to make movement feel more natural, whether you're idle, walking, or sprinting. You can see some of this stuff in games like Stalker 2 or other, I guess, modern games where they have a head bobbing in place that allows for the feel of the camera to be more natural. If you're into these kind of projects, feel free to check out my other work on the Fab Marketplace or on Patreon. You might especially like the WorldForge because it's an automatic landscape material system that lets you build stunning environments in just a few minutes. Alright, enough said, let's dive in. So the first thing I want to do is I want us to have a look at what we have so far from the previous tutorial. So in my world settings, I already have the FPS cinematic tutorial set up, so I'm just going to press play. And as you can see, we have our character, which has a little bit of movement as they walk around. They can also run. And when we get close to an object, the object becomes quite blurry, and so does the outside. But if we look further into the distance, we'll notice that the object near us becomes blurry, while the object far away becomes a bit more, well, basically goes into focus, right? So this is a very interesting way of doing things, but we obviously want to enhance this a lot more so we can have a lot more control. And that's what we're going to do first. We're going to upgrade our current blueprint so we have an up-close focus as well. So in order for us to do that, we're going to go back in here into our FPS cinematic. Obviously, with the project at hand, if you download it, you're already going to have all this set up from the previous tutorial, or you can watch that to do it yourself. I highly recommend, as I said, watching the previous tutorial. So the first thing we want to do here is we want to take all of this code, so all of this, we want to copy it, and we want to paste it up here, like that, okay? Now, the next thing we want to do is also we're going to delete this particular option, and instead we are going to divide by 1.2 here, and we're going to connect this over into our focal distance directly. Okay, now we're going to do that because we're going to use a different focal distance basically in our new depth of field for when we're up close to the object. Now we need to connect this much the same as this one here is connected. So we're going to take this node and put it into the start. We're going to take this node and put it into the end. We're also going to get the world location and plug it up here like that, okay, into this subtract. And once that's done, pretty much everything in here is in order. But we need to tell our, our blueprint when to use this. So for that, we're going to get a branch, okay? And the branch will run, if it's true, it will run this code. And if it's false, it's going to run this code. And we're going to take this plugin and, this node and connect it over to the branch. And we need a condition. So the condition for this to run is whenever the vector length, so that's basically the vector length of this branch here. It's another one that we just created, but the one that we already had. Whenever the vector length is lower, so we can put a less, so a less than a number. So when that is lower than 300 in this particular case, then we want to run this part of the code. And whenever it's over that, we want to run this part of the code. Okay, so what we're going to do is we're also going to draw the debug line. So I'm going to make this for the duration so we can see it, but we're not going to give a debug line to this one. So once we press a compile now and we press play, what you'll notice is that if we look downwards, there's a debug line because now the distance for our character's peripheral is actually closer than 300 units. And if we look away in the distance, now it's actually shorter, so we no longer see the new focal point. So now when I get closer to this mesh, you'll now notice that it's going to stay in focus while the rest of it onto the left side actually goes out of focus. So this is very important because it obviously works as intended. But we can do more here. We can also add a zoom function in order to use this so we can see very up close, see a lot of detail, right? This is going to help with the realism of the shot as well. So let's actually move on to doing the zoom function. Now, to create our zoom function is actually quite straightforward. We're going to make sure that we're actually pressing a button in order to activate it. So for me, it could be the right click button, but we're not going to do it in this particular way here, like we're, doing left shift to flip flop to walk and run. Instead, we're going to use another way. So if you have a look here in the first person character blueprint, you will have this area where it says IMC default, which is the data asset input mapping context. Okay, and you can create one of these if you want. So just look at the fact that it's an input mapping. So if you search for it in here, you'll be able to actually create a new one if you want. But if you open the default one, in here, you'll see that I've got a new mapping coordinate, which is a IA zoom for right mouse button. Okay, so in order for you to create one of these, you would click the plus button over here. And sorry, let me just click over here at the top. And this will create one, and then it's going to ask you to actually select what you're trying to, one that already exists, right? So in order for us to do that, we could right click in here, and you actually have to look at what it is, right? So what it's actually trying to create. If you go into actions, you'll be able to see them. These are input actions. So if you right click in here, you can type in input action, and then you could create one like that. And obviously you can rename it whatever you want. And when you double click it, all you have to do inside here is just make sure that you switch from digital Boolean to an axis 2D vector 2D. That's what you'd need to do. And obviously you'd want to name it whatever you want to name it. So again, for me, I've effectively created a new input action, right? So I could just take this and drop it over here like that, right? And then in here, whatever key I want to use. So if I press this keyboard and I right click, this is going to add it as a right mouse button, but you can obviously search into this list as well. And once that's done, that's pretty much it. Like you don't need to do anything else, right? From now on, the system will know to use the right mouse button for this input action. But I'm going to delete that because I've already got the zoom for right mouse button here. So if I'm here over into the blueprint, I can actually type in IA zoom, right? And if I left click it, this will bring the enhanced input action that we just created earlier, which is this one from here. Okay, so if I click over this button, we can see that we're going to have a started point and a completed point, which is very important for us to actually start our zoom. So our zoom is going to be a custom event. That means that we can right click in here and type in add custom event, and then we can call this start zoom. Okay, then we're going to press compile because I want to press this plus button over here, and I want to name this activation. Okay, and we're going to leave it as a Boolean. So we're able to actually tell our system whenever this is running or not, because we are going to go into a branch like this over here, and then we're going to connect the activation over to the condition. So we know that whenever we're starting to zoom, it's telling the branch either this is true or false, right? And what we're going to do here, we're going to add a lerp, right? And in this lerp, we're going to put it somewhere around here. It doesn't really matter, okay? But we want to create a new variable, right? Which is going to be effectively a focal length. But actually, no, we're not going to create a variable. We're just going to use the focal length of the camera itself. So if you click the camera, hold control and left click to drag it over here into the blueprint, we can now, pull from it a node, a pin, and we can actually type in current focal length. Okay, like that. This is going to give us the focal length. So I don't want that. I want to set it. So we're going to, again, type current focal length. We're going to select the set current focal length. Okay, so if it's true, if we're zooming, I want to run this code. Okay, so that's what I want to do. And I want to set the current focal length to whatever we want, right? So in this particular case, we want to go between a value of 30 and a value of 12.6. Now, here's the interesting bit. The alpha is going to determine if we're using the value of A or the value of B, okay? So we can plug this over in here. You got to make sure that when you click on the camera, and this I've set up on purpose, it's already done to 12.6, right? But you might have it, let's, reset this to default values. You might have it something like this, right? And if that's the case, then you want to switch over from, I'm going to go from digital film to DSLR. And you might not be able to change the current focal length in here, right? And if you're not able to change this, then you can always make sure that instead of being onto these prime lenses or whatever, make sure you go to universal zoom. And this will allow you to set this up to 12.6. Okay, and that's what you want, because you want your camera by default to be looking at 12.6, which is about 90 FOV for video games. Okay, and we want to zoom in, meaning that we want to go to a focal length of 30. So whenever we're running this code, it's actually going to do this for us, but we've got to tell it how and why this is happening. So whenever we have this started here, we want to type in start zoom. So this will execute start zoom, and it will put it as an activation. It will activate the Boolean that's activating the branch. And then when we say, well, you know what, the action is now completed, so we let go of the right mouse button, we want to again start zoom, but this time we're not actually activating, right? I'm just going to click compile here, and you might get an error. And if you read through the errors in here, it could just say could not find a pin for the parameter activation and stuff like that. So this could be an issue, right? Where these, you can see in here that we don't actually have the same parameter as the start zoom. I'm just going to delete these, and instead I'm going to drag my start zoom from there. You see, by actually searching for it, we're getting a problem, but by dropping it in, this is the right one. So we're going to do start, okay, and then I'm going to duplicate this and bring it over here. Just make sure that it's deactivated and then complete it. Now I'm going to press compile, and now it runs. Now the code will run, but it will actually only run if we go here where we have event begin play. Now, if you have my blueprint that you've downloaded, you should have the same setup with the sequence here. If not, if you follow the previous tutorial, again, you'll have the sequence. But if you're not, just make sure that you add the sequence in case you need it. So we're going to use another part of this sequence to start zoom, which means that when we drag start zoom over here, we can actually put this over like that, because we're trying to execute this when we're, when we're event begin playing. And we want to make sure that this is set to off, right? Because by default, you don't want to start zoomed in, okay? So we're going to press compile, and now we're going to go back into the scene and press play. Now you'll notice when I right click, there you go, we zoomed. The problem that we have is that we can't zoom out, okay? So we need to now add this particular point as well, and we're going to do it in such a way that it's like a smooth transition in and out, so it's going to look quite nice. And this is actually, again, quite easy, very basic stuff. We're going to use what they call a timeline, okay? So the first thing, let's just make sure that we create a new Boolean. So I'm just going to duplicate this one, it's fine, and I'm going to say we're going to have it is, well, actually, yeah, is, and then we can say zooming, okay? So then we know, I'm just gonna, sorry about that. I'm just gonna make sure that we're putting a B in front of this so I know it's a Boolean. So this is zooming is going to be a sort of a point of us asking the system if we're zooming or not, okay? And then I'm going to drag this in here as a set, so like that, Alt, and drag it in. And I'm going to do this twice. So if this is true, then obviously it is zooming. And if it's false, then it's not zooming, okay? And then over here, we want to add in a timeline. So just type in timeline. We're going to call this zoom. And then when this is true, we're going to reverse. And when this is false, we're going to play. That's what we're doing to this timeline, which we're going to edit in just a moment. Okay, now when we double click the timeline, in here we can create a new track. So I'm going to press on the track and add a float track. I'm going to call this zooming template or something like that, right? And then over into it, we have to set up the actual value. So I'm going to right click and add a key to the curve point, and then I'm going to right click again and add another one. Now we select the first one, and we need to set a value here in time at 0 and a value to 0 as well. So just make sure both of these are 0. Then we're going to select the next point in here, and this is going to be a 0.3, and the value here will be 1. Now, we want to make sure that the timeline is completely visible, so I'm going to press this button and then this button, and now both of the points are centered. I also want my timeline to only run for 0.3, so that's the length of the timeline. And I'm going to select this point, right-click it, and change it from linear to auto. And then I'm going to select this point, and again, right-click it and change it to auto, so we get this sort of like nice curve, right? So it's not a linear curve. It's, it's got a bit of, well, it's more smooth, basically. So now we can also rename, well, actually the zooming, the timeline can be renamed up here, so you can right click and rename it to whatever you want. But for us, we've named it zooming template. We're going to go back into the event graph, and you're seeing that we have the zooming template now added here. And we can use this to plug it into the alpha like that, and then the update into the set. Okay, this is in theory all we need to do now for this to work. There shouldn't really be any issue. So if we press compile and we go back into the level and we actually press play, if I right click, it zooms in, and if I let go of the right click, it actually zooms out. So this is really cool. And of course, if we get close to the object, we're not really getting any nice depth of field and a lot of clear, how should I say, focus on the mesh that we're looking at. So we need to rectify this by adding a new parameter for zooming where our depth of field is updated based on that. So let's do that. For when we're zooming, we want to again have a look and have a look at the condition. If we're actually zooming, so if this action, depending on what this activation here is doing, we want to make sure that we're running a new line of code for the depth of field. So I'm going to copy all of these elements like I did before, and I'm going to drop them down here so we know that these are for the zooming part. So again, we'll connect these nodes as we did before, like that. And we're using the same nodes because it's fine. We don't want to like create new functions for this. Okay, so that's pretty much connected there. But when it comes to actually, like the fine control over here for this, we want to get the vector length and put it straight into the focal distance, and we don't need a divide over here at all. Okay, we're also going to disable the visibility of this, this debug line to none, but we're going to add this one so we can see it whenever we're playing around with it. But now we need to tell the system when we're running this branch. So we're obviously going to add a new branch over here. And the condition will be that if it's true, as in if we're zooming, then we want to run this branch, okay? And if it's not true, we're not zooming, then we want to run this branch. And then this custom event here will run the actual main branch itself. So when we press compile and go back in here, now you'll notice that we're not getting any of the line trace visible again. But if I get close to an object and I right click, now we're actually zooming and getting a nice focal distance of this particular rock mesh in here when we're really up close there. And you can fine tune this based on this focal distance here. So you could change this. You could have math added here after the vector length to make it so it kind of functions the way you want it. So I'll leave that to you for your own sort of play to see what you want to get there. But that's kind of how you refine for right-clicking when you're, for zooming and getting, the focus onto what's in front of you. So this line is effectively hitting any collision in front of it, and that's where your focus is then being set. Now for the next point, I want to add a bullet time system in here. So it's very quickly, very, very fast. I'm just going to type tab so we can actually find the tab key. Then we're going to use this as a trigger point for our slow motion. I'm going to also check for a flip-flop node in here. And then I'm going to use the A and B to dictate this. So what we need is another timeline added. And we're going to call this slow-mo, so we know this is the slow motion thing. Then we can double click it so we can open it very quickly. And then here we're going to add a new track, which is going to be, again, a flow track. And then we can call this, I don't know, bullet time or something like that, right? And then we want to add 2 points again. Select the first point and just make sure that this is actually going to a value of 0 for time and a value of 1. And then we can select the second point, and this can go to a value of 0.5 and the value here 0.3. Then we're going to click on these 2 buttons to make sure that we center them. And we want to make sure that our timeline is not bigger than 0.5. So again, the timeline length here can be changed to 0.5. Now we want to, for both of these points, select them and change them over to auto again, like that, so we get a nice curve. Then we can go back into our event graph here. And we want to make sure that for A, we're playing. And when we press, when we press B again, we're just reversing what we've done, reverse the timeline. And then for the update, we want to set global time dilation. And where it says time dilation here, we want to put a bullet time in there like that and press compile. Now if I'm back in the level and I press play, you'll notice, so I'm running around. If I jump and press tab, this is now in slow motion. So now I'm not in slow motion anymore. I'm just moving around very, very quickly. So let me just try and, press tab again, and you'll notice that I am moving in very slow motion, right? So, and this, if I press tab again, it will release and I can move fast again. Okay, so this is really cool. And now lastly, what we want to do is the head bob animation. So this is going to be quite an interesting one. We're going to have to actually create the head bob animation. So the first thing we want to do is press this plus button over here. Over here, the functions. And we're going to call this head bob, not bomb, animation. Okay. And this node is going to be quite straightforward. There's not a lot going on. We're going to get a branch here. And then we're going to duplicate this branch over here like that. And if the first branch is true, then we're launching the second one. The first branch is going to serve for when our character is standing. So if he's not standing, we're going to go to the second branch. If he is standing, then we're going to do an idle animation. So for us, the idle animation is going to be based on, we're going to type in here, start camera shake, but we don't want this one. So we're going to untick the context sensitive, and instead we're going to want the client start camera shake like that. We're going to use this one. Okay. So this is going to be for idle, just so we know, right? And then what are the conditions that are, telling our system to either use this one or to use what this branch is going to do for us? So this is actually quite simple to do. What we want to do is first we want to get the velocity. This is the velocity of our character, and we want to calculate its XYZ axis to a vector length. Oh, not vector left. We want vector length. Okay. And again, this is the one here, vector length. So we're transforming the velocity into a float. And then this float value, we want to make sure that it's higher than 0. So we're going to put a greater symbol here. So if this is greater than 0, and we're going to add an and boolean here. So if this number is greater than 0 and our character can jump, so we're going to search for the node can jump and plug it in there. If it can, then do this branch. But if the character's velocity is 0 and our character can or cannot jump, it doesn't really, you've got to have both of these options. If he cannot, if the character is not jumping and he's not moving in any direction, that means that he's idle. So that's when we're going to run this code. But if he is moving or jumping, then he's not idle. So then we want to have 2 more points over here. And the first one, this one could be for walking. And then the second one can be for sprinting. Okay. And this is going to allow us to use a camera shake in each of these slots based on what the character is doing. So Right now we have another condition here. So what we're saying is if the vector length is actually smaller, less than, so we're going to put in here the number 200, then do this particular branch, okay? So if the number is less than 200, then the character is walking, so you want to walk. And if it's higher than 200, then he's running, sprinting. So we want him to sprint, right? We want the head bobbing of sprinting. Now, these particular fields in here have to be set, but let's first go back into our event graph. We want to make sure that we bring our event tick into this, and that the event tick is actually running the head bob animation. So like that, otherwise we won't be getting the camera shake, okay? We're going to compile, and we are getting an error somewhere, which is in here in the head bob animation. We do have to set up these options. So if we go in here, right, let me just delete this new input action because I'm not using it. Over in here, I have a BP camera shake for idle, sprint, and walk. Now, in order for you to get this, you can right click and create a new blueprint class. Then over here where it says all classes, you type in camera shake. And I would like you to use the legacy one. So for me, well, you can see these three that I've created, but I can also just press this button, this one, legacy camera shake, and then press select. And this is the one that you'd have. Now, if we double click it, we can edit all of these options in here, which are going to kind of determine how much wobbling you're doing with the camera shake. But if I am going to open the idle, this is the idle. So we just pause the video and copy these values for your idle one, then create one for walking and one for sprinting. I'm going to show you the sprint one now. So again, pause the video and copy these values. And also here is the walk one. So again, pause the video and copy. Now make sure for all three of these, so for the walking, sprinting, and idle, you check the single instance box. Make sure you do this, otherwise it will not work. Okay, once you do that, okay, and you save them, you can now go in here and, for example, for me, the idle one, I can set it up in here in this slot. Now, it's not going to allow me to drag and drop it. So I'm going to have to click on the select class. I'm going to put in here idle. And in here, I'm going to put sprint. And in here, I'm going to put walk. And now I'm going to press compile. And, oh, I'm still getting an error there. So I think the reason why I'm getting an error is because I don't have a target. So the target for this needs to be the player controller. So just make sure that you select get player controller, which is this one. And then we will plug this into the target like that. And this will be fine. It will function after this. So press compile. What other error am I getting? Oh, yeah. Sorry, it shouldn't have been target player state. We need to get player controller. Sometimes in order to get the proper one, just press the context sensitive button over here. And we want to get the player controller for the game, right? This is the one that we want to get. So I'm going to hold control and drag this pin over here. I'm going to delete that and press compile now, and it's fine. Now, if we go back into here and press play, you'll notice that our camera is wobbling a little bit. Obviously, we can change the intensity of the idle animation, but if I move around, this is how much it's wobbling right now, which maybe is a bit too much. And if I start running, this is how much it's wobbling right now. So again, you may want to change your settings to get the wobble that you want, but obviously, this is really down to you, like what you'd want to do, okay? What sort of settings you want to use. And that's about it. That's how you get camera zoom, better depth of field, slow motion, and also head bobbing inside Unreal Engine for a FPS camera. Now, thanks a lot for watching, guys. I really appreciate the support. If you enjoyed the video, don't forget to leave a like, drop a comment, and hit subscribe if you haven't already. If you want to dive deeper or support the channel further, feel free to check out my Patreon for more content, free projects, and behind-the-scenes stuff. And as always, keep creating, and I'll see you in the next one.